Why quantum mechanics? What is the sense of going through all this stuff with differential equations and all the complex math that comes along with it? Why not just stick to Newtonian mechanics and leave it at that? Doesn't that explain everything? Well, one thing that comes to mind is, have you ever taken a chemistry course? Well, if you have a chemistry course, then you know that the atoms are divided up into little categories, and those atoms bind together because of quantum mechanical rules. So, what are the quantum mechanical rules? One of the big things is the electrons. The electrons bind together either in shared formats, like a covalent bond, or one atom gives up an electron to the other and you have an ionic bond. So this is nature of reality. And a lot of people don't like physics, but they do like chemistry. Well, that doesn't make any sense. You've got to have the physics behind it. So I am at that point, and the reason I'm making this video is I'm at that point where I'm wondering, do I want to go on and attack the math? Because in a couple of my videos, I was going to say, okay, let's do the hydrogen atom, do the quantum mechanical thing of the hydrogen atom and build up from there. The simplest atom you can probably come up, probably, of course, it's the simplest atom you can come up with. Some of the binding things that were there in the Big Bang, and that's all you had was hydrogen. So why go through all this stuff? Well, you know what? If I go through this, then I might actually come up with a good idea. Now, people like Feynman and other people like that, didn't necessarily invent things, but they came up with new approaches to things. So why not go after that? I'm retired now, so I can pursue that kind of thing. And maybe you can live through me through this video of maybe your own frustration that you might have getting into this kind of stuff. So I'm not a genius. No way. I'm not a genius. So I have to accept that. And I have to accept that it's going to be a long road to victory of figuring out some of this stuff and being able to look at discoveries that are being made now so that I can figure that out. So I gave up. I'll admit that. I gave up when I got to the math on the harmonic oscillator. If you remember, I said, do some hand waving and look at this other video. And when I got to the rigid rotor, it came up, I did all the classical mechanical part of it. And then when it came to trying to quantize all that energies, then I said, oh, give it to this guy and make him. Well, I looked at those videos and I didn't like those videos. Originally, I said, oh, this is good. Whoever's watching my videos, just do that and let them do the math. Well, the whole idea for doing these videos was so that I could learn. So I'm going to have to do the math. So I'm going to have to back off before I get to my goal of the hydrogen atom. Or another approach is to do the simple setup. Simple, oh, that's what I say. Maybe you say it's not so simple, but do the simple setup of the hydrogen atom and then say, okay, let's go back and do the math before we go on to other subjects. Remember, this title of this video or the title of this playlist is In Search of a Quark. So a quark is something that an atom, you can come up with ideas like that, but now when we get to the proton, you can come up with that, electron, you can come up with that. But when we come to the point where we say, oh, what is this interior of the proton? Interior of the proton? What could we possibly say that the proton isn't the elemental things? Well, I've got a chart on my wall that shows that there's other things. There's other things beyond that. And let me quickly look at the chart. Okay, excuse the interruption. When I look at the chart, it shows me that there are nuclei of atoms that are made of protons and neutrons, and those are made of quarks. So we better figure out what a quark is. Because if we're looking at the physical reality that we live in, we got to deal with quarks. And there are charmed quarks and all sorts of weird things that don't make any sense. And the guy that Murray Gell-Mann, who came up with the idea of a quark, he was trying to be really funny and really clever, and it was from some story that he read and that kind of thing. So I'm not real knocked out with the name of the quark, but let's see what he came up with and see if it makes sense. Again, a lot of people dismiss that Murray Gell-Mann was so smart, but I think he was probably influenced by a lot of other people, and then he just took that little baby step up to that thing. Okay, let me leave you with this last idea. We went to a free particle, which was simple to do. Then we did a particle in a box, which wasn't quite as simple, and we found out that the energy modes are what they say quantized. And then once we went from the particle in the box, we went to the harmonic oscillator, which I represented as an object on an air track. And then and then I got to the point where I couldn't do the math. So we got to do the math, got to go back, got to do the math, or we can't move forward. And then I went to the rigid rotor, and that's a rotating thing, angular momentum and those kinds of things. And I got to the point where I couldn't do the math on that. Well, maybe I'll set up the hydrogen atom next, and then we can come up with the stuff that that's made of, and then get to the math there where we stop, and then let's learn some math. Go back to some basics. I'll have to do some math videos. And if you say, oh, well, I'm smart in math, I don't need that, well, then don't watch them. Don't watch those videos with the math. If you think you're so good, then go ahead and wait for me to come up with those where I introduce the math and we come up with some more conclusions. Thanks for listening. Comment, comment, comment. If you hate it, if you love it, that's what I want to hear.